Hi, everybody, and welcome to this new episode of SageMaker Fridays, Season 4.
Season 4.
My name is Julian, and I'm a principal developer advocate focusing on AI and machine learning. And once again, please meet my co-presenter.
Hi, everyone. So my name is Ségolène. I'm a senior data scientist working with the AWS Machine Learning Solution Lab. My role is to help customers get their ML project on the right track in order to create business value as fast as possible.
Thank you for being with us once again. So in this new season, we actually have 3 parts. So the first part is about building models, building high quality models. So we look at things like data prep, feature stores, bias analysis, etc., etc. Okay. And so today we're going to look at a financial services use case, fraud detection. Okay, but we'll talk about that, of course, in a few minutes. Then we have a second part in the season where we'll revisit some of those use cases, but focus on automation and ops in general. Okay, and finally we'll close the season with a third group of episodes on AutoML, where we go the easy way, maybe. Let's see. And just let AutoML build models for us. Okay, cool. And I guess we can compare them to the other ones and hopefully, see that we've done a better job. So this is the GitHub repository for today's episode. Okay, so take a screenshot. We'll show it again at the end of the episode. Okay. If you have any questions during the episode, please ask all your questions. We have friendly moderators who are here to help, so make sure you learn as much as possible. Okay, so let's get started. So Sego, what are we doing this week?
So this week we are going to work on a fraud detection use case. We will try to figure out if an auto insurance claim is fraudulent or not.
Okay.
You love fraud detection, right?
Yeah, it's a good use case.
And we will also analyze a bias in the dataset, and we will apply mitigation techniques to build a better model with maybe a better accuracy.
Okay, interesting. So a reasonably, and let's look at the pipeline. A reasonably simple problem. Okay, we have claims for car accidents. So we'll see the dataset in a minute. Plenty of information on the claim, on the users, etc. And obviously, we want to figure out if this is real or not. Or we're trying to, steal money from the insurance company, which is not a good thing. Okay, generally. So, so this is the pipeline, so to speak, the architecture we're gonna work on. So we'll start from a CSV dataset, which is reasonably simple, and then we're going to process it. Okay, so we have processing scripts that we can apply, and then we're going to train a model, and we're going to run a bias analysis using SageMaker Clarify. So we'll see if we have any potential bias issues, right, and what those are, and then we'll work on trying to fix those issues using mitigation techniques, and we will train again. Okay, and hopefully by doing so we achieve 2 goals. First, we remove potential bias, and maybe we get a better model. We get a more accurate model. Okay, so let's see if we can get this done. Okay, all right. So yeah, why don't we get started? Let's close this slide. Okay, we'll go back to the repo later on. Okay, need my demo glasses on. And here we go. Okay, so first things first, I guess we need to look at the data set, because the problem is really it's binary classification, right?
Yeah.
So let's look at the data set right away and see what we have here. Okay, and it's not very large, right? It's not a huge data set.
No, it's 5,000 claims and 5,000 customers.
Okay, so small scale, and yeah, so training will be fast, but still, it's an interesting data set, and I think it's synthetic
data set.
Okay. All right, so it's completely fake, right? No personal information whatsoever. So if we look at the claims data set, we see, okay, so we have a policy ID. Let me zoom in maybe a little bit. Who the driver is, right? With respect to the, I guess, the owner of the policy. Is it the person itself? Is it the spouse? Is it
The child.
child?
Child.
Yeah. Yeah, I never crashed my car. This seems to be a popular thing to do when you're 18. What kind of incident you had, where the collision took place, how bad the incident was, you know, how many vehicles were involved, did you crash on your own or did you crash into someone else, number of injuries, that's not so funny, police reports, date, and yes, of course, the fraud, the label. And we can see lots of zeros.
And sometimes.
Okay, a few ones. Okay, so that's good. Well, I guess that's good, right? Most people are honest, like me, right? But some people are trying to, you know, steal from the insurance company. Not nice.
Not nice.
Okay, so that's the claims data set, and let's try the customers data set. So obviously, okay, policy ID, customer age, how long you've been a customer, number of claims in the last year, which state your policy is registered in, your premium, you know, lots, gender, which should be looked at, right? Because usually, you know, potential bias lies in what we call sensitive attributes.
Sensitive attribute.
So, you know, gender, ethnicity, you know, maybe education, maybe other things. So I would say personal, very personal things. So we can take a look. We see, unfortunately, we have missing information. So, you know, male, female. Okay, we'll go back to that. But let's keep a note that, yeah, we're gonna look into this. Okay. So as you can see, simple data set, and a reasonably simple binary classification problem. So here we see numerical values, we see categorical values, same here, right? Yeah, so for example, severity is clearly a category. So, you know, we need to apply processing, okay?
Yes.
We can't just go and train like that. So what are we going to use for that?
That formula, SageMaker?
Yes. All right, SageMaker Data Wrangler. Okay, and if you watched last week's episode, we already covered it. But let's look at it again. I think it's you know, it's a reasonably simple way, intuitive way to work on your data. So for example, let's look at maybe claims. So the first thing you do is you import your data, which is just, you know, one click away. Here's my data in S3. Okay, go. And then you, all right, you see your S3 data source. You can apply data types. Data Wrangler will generally pick up the right type for each column, but, you know, you may want to double check. And then, of course, you have steps. So here, you know, we've done this again previously because there's no point in watching me click 32 times, creating 32 transforms. So let's take a look and see what those look like. So we have quite a few, right? We see custom pandas, we see string formatting,
encoded,
one-hot encoding for categorical variables. Again, applying types, etc., etc. So maybe let's look at strings, see what we've done here. Okay, so here we see a sample of the data set. And we see the list of transforms, and we have, you know, hundreds of transforms, you know, missing values, outliers, working with columns, you know, all kinds of things. Just go and explore, and you know, when you don't find what you need, then you can apply custom. You can apply custom formulas, and you can apply custom transforms, PySpark, pandas, PySpark SQL. So reasonably flexible. Okay. Okay, so what did we do here?
Remove symbols.
Okay, so for example, here we removed symbols from driver relationship, just in case we had any weird thing in there. You never know, right? Data is messy most of the time. So that's one example of cleaning your data. I'm guessing we've done the same. Yeah, we're doing the same on collision type. So you can quickly iterate interactively here and add your transforms and build that list of transforms that that clean up your and prepare your data. Okay. I guess we've done similar things on we've done similar things on customers. So we see again one-hot encoding. We see some custom pandas here. Oh yeah, replacing education levels with actual integers. So there's actually a built-in transform for that, I think. But why not? You could do it this way as well. Yep. Again, more custom pandas.
I think this one is custom pandas. No, it's not with the time.
So this one is actually it's this one actually creates a new column and inserts a new column with a timestamp. And we're doing this for the other data set as well, and we'll need this for the feature store. We'll get back to that, but yeah, it's we can see it here, right? And it's always the same value because it's okay. The timestamp is now, and just store that value, and that will give us a timestamp for this version of the engineered feature. Okay, but we'll talk about that later. Okay. All right. So now we've done those different things. Okay, on the two data sets, and now it's time to process the data. Okay, so there are many ways you can do this. Okay, so here again, this is kind of a preview to check that the transforms work as intended, and that you've actually implemented cleaning and engineering the way you want it. Now, if you want to run this on the full data set, you can actually export your steps. So you can select the steps
you want.
So if you wanted to skip a step or try different variations, why not? Okay, so I'm not going to select them all because I'm not going to click 19 times, boring. But okay, select all your steps, and then you have this export button that appears, and then you get 4 options. Okay, so I guess the basic one would be, I just want to apply all those steps to my data, and please save the result to S3. Okay, so you can do this with SageMaker processing in a fully managed way. And that's all there is to it. So this actually creates a Jupyter notebook with all the, why don't we do this? Click, okay, all right. So we have a generated notebook. Okay, we've got our inputs, so the data set. Our output will be the process data set. We upload the inputs to S3 and we run. That's it. Okay, so you can just run this, nothing to edit in there, just go and run. Okay, and then you end up having your process data in S3. You can export this to Python code. Okay, so this will be independent of any AWS service. So if you want to bring that code into your machine learning project, it's pretty nice. You can export it to another notebook that obviously transforms the data and uploads it to Feature Store, which is actually what we've done for the rest of this example. And you can export it to a pipeline built with SageMaker pipelines, but we'll get back to ops and automation in another episode. Okay, so all those options are one click away. And so here, in the interest of time, we have processed versions of the dataset. You can find them here, right? Okay. Claims processed, customers processed. But yeah, please feel free to go and actually export and run the processing job, and you will actually find those same files in S3, exactly the same. Okay, yeah, maybe we can open one of them and check that it's actually doing what it should do. So we should see, do we see one hot encoding?
Yes, the second one. Incident severity was minor.
Oh yes, okay, yeah. So this one has been encoded to integers, and driver relationship has been encoded. two integers.
Yeah.
Yeah, we see. Okay, we actually see one encoding here.
Yeah.
So self, spouse, child,
other, okay.
etc., etc. And a few more things. So hopefully, all those things we've done are actually reflected. Oh, collision type.
Collision type as well.
Yeah, we can see. Okay, so it's in there. All right, it's in there. So now we have a reasonable data set. Okay, fine. And I guess the other one is fine as well. Okay, so once again, you have in the repo, you already have those. So if you want to skip processing and jump to training, go and do that. But please explore the other steps. Okay. Okay, so now that we've applied all those, I would say, reasonable transformations, let's visualize the data. And again, I guess you could visualize the raw data as well. But here, it's more, it's more cleaning and the really basic stuff that we've done. So I guess it's fine if we visualize the process data. It's still reasonably easy to understand. So we load the pre-processed files, and for example, we can plot gender. So obviously, we see some imbalance, right? Is it a problem? Is it not a problem? It's hard to say. It's not very severe imbalance.
No.
It's you can see the ratio is okay. So we have about 70% male and about 30% female. So it's not huge imbalance. I mean, some problems have 1 to 100
exactly,
or 1 to 1,000 or even more. Sometimes extremely imbalanced problems. 1 to thousands, and that's very, very hard. Here, okay, we could say, well, maybe we still want to fix it. Okay, maybe we actually have to fix it. Maybe we have regulations and rules that mandate that we balance.
Balance that.
Okay. But okay, for now, let's just go and train like this, and you can see if this is a problem or not. Okay. Okay. Another thing we want to maybe try is plot fraud versus non-fraud. So, like I said, most people are really honest.
Honest,
Yes. Thank you, honest people. And we have a few percent, I guess, fraudulent transactions.
Good
so
news.
Yeah, so that's a more imbalanced problem, right? Here it's more 1 to 100. So we need the model to really work hard at picking up the fraudulent transactions here. Okay, and we could keep plotting education levels and the amount of the claim amount. We could also look at fraud by gender, and we see the ratio is really kind of the same. So it's about the same. It's about the same ratio as the number of male and female customers in that data set. So it looks like you have as many honest men as honest women. So that's pretty good. We all knew that. But okay, so it looks like we don't have a problem here. We just have an imbalance on gender, but probably not on fraud. There are more visualizations below, but again, you can keep exploring. There's lots of cool stuff in there. But in the interest of time, we want to spend more time on the other parts of the demo. But yeah, please read the rest of those notebooks. Okay, so we have processed data. We see some imbalance on a sensitive feature.
Attributes, yeah.
Okay, so but let's keep training, and then we'll see. If there's a problem or not. Okay. Okay, so we have processed data. Okay, so again, we're using those pre-processed files, but if you had run your SageMaker data wrangler flows, you would have the same. So now we want to move that processed data to SageMaker Feature Store. Okay, and so that requires a schema. Okay.
Okay.
And there are really two ways to do this. You need to describe the data that you're going to ingest in your feature store. So you can have this explicit JSON dictionary with the types. Okay, and you can apply them when you create the feature group, or you can let feature store infer the types automatically when at ingestion time. Okay. And in this case, we're ingesting from a pandas data frame, so you could do that. You pick your option. Personally, I prefer to be exactly sure what gets ingested. But if you're 100% sure that your pandas data frame has the right types, then that works. Okay, that works too. All right. Okay, so now that we've done this, we can move and create our feature groups. Okay, so again, feature groups are objects that reflect the data source.
Okay.
So here we have CSV files. We could have SQL tables or Athena tables, whatever. And generally, you want to have one feature group per data source. Okay. But in last week's episode, we also created a feature group from a table coming from a join query, right? So you can you can be very flexible here. But here in this case, we'll have one feature group for claims, one feature group for customers. So you just give them a name, right? Just like that. You load your feature definitions, so those schemas we just saw, okay? And then you call create to create them, okay? And you have, once again, those two important columns.
Record.
Okay, so record ID.
And event time.
Okay, so what are those for?
It's the primary key.
Yeah, so record ID is really, is the unique ID that describes a row in the feature group, okay, corresponding to a row in your data source. So it's kind of a primary key, right?
So the event type.
And the timestamp, which you mentioned earlier, where we want to set the time at which the feature was created, because over time we could manage
the different versions.
We could manage different versions. Okay. All right. And obviously, in this case, for the claims, we use the policy ID as the unique ID, and I guess we're using. We're using that. We're using the policy ID in both cases because it's present in both datasets. So that works. Okay. So we create the two feature groups. All right. And we wait for a few minutes for those objects to be created. That's super fast. And now we are ready to ingest. Okay. So in last week's episode, we actually run SageMaker processing job where we ingested automatically. Here we're using a different technique where we explicitly ingest the data in the running that code in the notebook, right? Not on managed infrastructure. So basically, you just call that Ingest API. You pass your data frame, the number of threads, and whether you want to wait for the operation to complete or not. Okay, so pretty simple. And if some rows fail to ingest for whatever reason, you get the row IDs and you can retry them. Okay, so we push all that stuff, and so what happens then is that data is written to S3 in what we call the offline store. There's also an online store that you can use for prediction, but again, we'll probably talk about that in future episodes. Here, we're basically pushing that data to S3 in a well-defined format with the timestamp and everything else. Okay, so we wait for a few minutes for all the data to flow. We check the actual bucket for objects, and okay, once we see those objects flowing, then fine. Okay. So so at this point, we've processed the data, pushed it to the feature groups, and now it sits in S3. Okay.
Perfect.
Okay. So now it's time
to train.
It's time to train. Okay. So so what are the main steps? Well, first we need to build a data set, right? And you can say, wait. We have a data set, right? It's in there. Well, we have data sources, right?
Ah, that's the difference.
You know,
That's a nuance.
we have data sources, and maybe maybe we need to do a little more, right? So the thing is, sometimes you have like maybe everything is your CSV file, right? So the data set is actually one CSV file, and that's it. So in this case, fine, you could work straight from there. Here we see we have two data sources. Some machine learning problems have maybe 20, 50 data sources.
Yeah.
And you want to use different features, you want to try different subsets of your data. So that's why feature store is really interesting. So you just process everything, push everything to a feature group or feature groups.
You can pick
and then you can pick what you want. Okay. And this is what we're doing here. Because when we create those feature groups, we automatically create a table in Amazon Athena. Okay, so let me show you the Athena console here, and we see those fraud, detect, demo, claims, and we see all the information here. Okay. And I guess we can preview it. Okay, well, no surprise, right? Okay, so what you see here is Athena querying the data in S3. Okay, so I didn't create something extra. Okay, I open Athena and run this thing automatically. Okay, so there's no other table, there's no other backend, there's nothing really here. There's data in S3, there's a table and a schema automatically created in Athena, and then I can go and query that stuff.
When you use feature store.
Yeah, so that's nice for even for data exploration. It's super useful, and of course we have the same for customers, and we can preview it. Right. So that's right there. So so we could actually write the query here, and then when I'm experimenting, that's exactly what I do. I write the query here, and then when it works, I move it back to the notebook. You need to put quotes everywhere, double quotes.
Don't forget.
Yeah, because the main reason is those table names have dashes, and yeah, see, so you need to escape them, otherwise this creates all kinds of syntax issues. Yeah. Okay, so the query here is basically a join, where we join claims and customers on policy ID. Okay. So that now, so here's the actual query, okay, and then we run it. Okay, it runs very quickly, and actually, why don't we? I'm gonna try something silly. Why don't I try this? Sego is stressed.
No, I don't like him. I think it works. Perfect.
All right.
Perfect.
See? Machine learning. It's SQL and CSV.
Oh my god.
Okay, and now we see our data set, right? So now what we have is, we have the policy ID, and then we have the claim ID somewhere down there, and we have everything on the same row.
Perfect.
Right? So not too hard. Okay, so we run the query. We get the result as a data frame, and yeah, by the way, it's you can also you could save the result. You could export the result as a CSV file. It's in S3. Blah blah blah. It's very easy here. But here we want to continue with our notebook. Okay, so move that to data frame, and yeah, we see the same thing. Okay. Okay, so now we're starting to, and we're saving that to a CSV file. One thing we need to do, because we're going to train with our good friend XGBoost again, is we need to have the label at the front, okay? Which is the next XGBoost requirement. The first column needs to be the label, so that's not the case here, which is why we just move the fraud column to the front. And so yeah, we drop the and yeah, we just split for training and test. We save to CSV files, and we upload that stuff to S3. Because again, that's where SageMaker wants the data. Okay, so we see the training set now is fine. Fraud is the first column, and then we have all our features. Okay, and we can move on to training. Okay. Makes sense?
Makes sense.
Yeah, so good. So far, so good. Not too hard. Okay, now we're ready to train. So training here is really, really super simple. Let's move straight to the good bit, which is this. We define, yeah, you can read all of it later. I just want to show you the good bits. We define the infrastructure requirements, okay, that SageMaker will manage automatically. And then, okay, we define hyperparameters. Okay, so it's a logistic regression, binary classification problem, and these are the vanilla hyperparameters, right? For XGBoost. You can use the one you already know. Then we create an XGBoost estimator. So XGBoost in SageMaker is available as a built-in algo and as a framework. So the built-in algo doesn't require any code from you, right? It just requires a data set. If you want more flexibility, you can actually pass a script, and this is called framework mode. And here we can actually see this little bit of script that receives the hyperparameters on the command line. So this is called script mode, very useful feature in SageMaker. And then the rest is vanilla XGBoost, right? And then at the end, we save the model in a well-known location. So that's very, very nice. Okay, so we configure our estimator. Here's our script, infrastructure requirements, hyperparameters, where to store the model, and then we call fit. Okay, and so that creates that manage instance, and it loads the XGBoost container, the script, the dataset, puts everything together, and off we go. And it trains for 77 seconds. And AUC, which is the metric we use here, is 0.79. Okay, let's try and remember that. Okay?
We try.
Okay, so we train the model, and it's okay, I guess. It's not awesome, but it's okay. Now, maybe we have second thoughts about that gender imbalance. So, okay, let's pause and let's jump to this, okay? And using a capability called SageMaker Clarify, we can run a bias analysis on our dataset, okay? And this is really pretty simple. So you need to set up a couple of objects. So again, infrastructure requirements to run the analysis, the dataset config. Okay, so we're going to run a pre-training analysis on the dataset. We can also run a post-training analysis. So on the model, this is optional, but we have a model here, so we can do both. Okay, see if bias that was in the dataset is still in the model. It could be worse, could be better, you never know. Okay, so what model to use, and then what to look for. So here we have this bias config where we say, okay, you're going to look at customer gender female, which is the one hot encoded column, which has a value of 1. So for instances that have this column set to 1, compute bias metrics for label 0, meaning not fraudulent. So does this value, so do female customers suffer from some sort of bias on being predicted as honest. So in other words, do we predict female customers in an unfair way?
Okay.
Right? Because there are fewer of them in the data set. So maybe the model doesn't learn as well. Okay? All right, so we run the bias analysis, computing all metrics, right?
Okay.
All right, so this runs for a little bit, prints out all kinds of stuff. So we see the metrics here, but you don't want to read JSON.
No.
All right. What you want to look at is
a beautiful report.
It's a beautiful report that we see here. Okay. And you can find it. You can see all your training jobs here.
Experience.
Yeah, and you can see the explainability job. And if you open it if open details, you see that, right? That's where it came from. Okay. Okay, and we see metrics. So we have, like I said, pre-training metrics, post-training metrics, and we see class imbalance. Okay, so yes, there is imbalance. We actually saw that in our visualization. We have all kinds of bias metrics. We have no time to discuss them in detail today, but you can find you can find more information by clicking on some of them, or all of them, I should say. And you can also find white papers and additional information online on the SageMaker in the SageMaker documentation. So we see class imbalance, and generally those metrics are okay when they're set to 0. Right? 0 means fine, non-zero means a little bit not fine. So we can see there are some differences. I have to say they're not huge. Okay, they're not hugely worrying metrics. No. Okay, but you could say, well, this is
at least this is quite significant. So.
This one needs to be looked at. So you could say, okay, let's try and rebalance the data set and train again, right? And see if we actually have a better model on it. Okay. So the imbalance problem generally is something you want to fix, and it's easy to fix. So how do we fix it? Well, so basically the problem we have is we have too many men and not enough women. So you could go two ways, right? You could remove men to rebalance, or you could add women. And there are many ways, or different ways to add women. You could actually duplicate existing samples. That's one technique, right? And it sounds weird, but it works okay. Or you can create new. So you can create synthetic samples, and that's what we're trying to do here. So tell us a little bit about mode.
Yeah, no, this is when you've got imbalance data. So as you said, we can either undersampling, oversampling, or using some synthetic data, using SMOT, synthetic minority oversampling techniques. And you're gonna, in a nutshell, you're gonna generate a new instance for the minority class.
With the same quote unquote statistical properties.
Exactly.
Right?
Yeah.
Okay. So that's the math, and if you want the math, it's on that SMOT documentation, and beats me. So I'll trust it to do the right thing, which probably is not the right approach, but that's the only one I can take. So we can see initially, we have here, we have this number of men, this number of women, not good. So which is really cool, this library, which is called Imbalanced Learn. Very, very useful library. It really takes one line of code, right? So all you do is this, right? You create your SMOT object, and then you say, okay, resample, bam. And now, so obviously we kept all those men samples, so to speak, and we have the same number of women samples.
One line of code, can you believe that?
Yeah, very nice, very nice. Yeah, it'd be very painful to do the same yourself.
Yes. Okay,
so now we've solved that balance problem, so we can train again. Okay, so exact same code, right? Exact same script. Run that, create our estimator again, train again, and then let's see what we get. So interestingly, we see that AUC has significantly improved, right? Almost 6 points. So that's very significant, right? So it's really interesting because it was not such an imbalanced data set, right? But just doing that rebalancing is improving the accuracy, because I guess you just give more samples to the model, right?
To learn on. Yeah.
To learn on, right? So it gets a better shot at, okay, these are the male specific patterns, and these are the women specific patterns, if there is such a thing, but apparently there is, right? So just giving more data to the model increases accuracy. So I think it also tells that SMODE is doing a good job.
Yeah.
Right? Because if those synthetic samples were crap, excuse my French, accuracy would, our AUC would actually be horrible.
Yeah, exactly.
So well done, SMODE.
And maybe we can check the final metrics.
Oh yeah, and
the bias metric.
Yeah, so we can run bias again. So it's the same. Yeah, the code is below. You can run it yourself. Again, it's exactly the same. And so if we look at the bias now, we can see, well, class imbalance is 0, because guess what? We made it. We made it 0.
We made it 0.
Okay. And the other metrics didn't change much. So we would need to dive a little deeper and see, maybe build a confusion matrix. Because apparently, we're predicting better. So, are we predicting better for men? Are we predicting better for women? Are we predicting better for both? Where does that extra accuracy come from? We would need to go and investigate a little more. But as you can see, it's really easy to compute those metrics, and in a few minutes you get a good sense of what's going on in there.
Thanks to clarify. This is really nice.
Very nice. It's it's a really cool and really easy to use service. So again, we're doing pre-training and post-training, but you could do pre-training only if you just wanted to analyze your data set. Okay, well, I think that's pretty much what we wanted to show you today. So to recap everything, what did we look at? So we started from a binary classification problem with two CSV files. We imported them in Data Wrangler. We processed them using a list of transforms. We uploaded them to SageMaker feature store. That makes it really flexible to pick what you want in that data using Athena. Run some queries, build some data sets, train some models, evaluate them for accuracy, AUC, but also for bias, and clarify makes that really easy. And I guess we'll come back to this. There are a few more things we want to show you here, on deployment, registering models, automation, figuring out, model and artifact lineage. There are all sorts of good things to discuss. But it's the end of this episode, and so we'll be back in September with and we'll take another look at this. Okay, so let me show you. Let me show you the repo once again. If you want to take a screenshot, okay, and this is the one. So go and run this. Have fun. Ask your questions. Get in touch. And Sego, thanks again for your help in preparing and delivering this. And we'll see you next week with another example on
detection concept.
Oh yeah, the computer vision. Oh yeah, computer vision example on cancer detection. So not a funny topic, but a really important topic, and we'll see how machine learning can help working with image data sets. Okay, so hopefully we'll see you there. Okay, so on August 20th. Okay, Sego, thanks again.
Bye bye.
Bye bye everybody.
Bye bye.
Have a good week. See you soon.
Bye
Cheers.
Bye. Cheers.